Hey guys, this week we're going to talk about counting principles. And we're going to start with the most basic one, the fundamental counting principle. So, the fundamental counting principle is just basically that if you have a bunch of different spots, the number of possibilities for each spot, if you multiply them together, that's going to give you the total result of the possibilities you can have. So let's just take a very basic example. Back up until 2005, Rhode Island license plate numbers were 2 letters, followed by a hyphen, then 3 digits. So it was letter, letter, hyphen, digit, digit, digit. So that means in the state of Rhode Island, you could have A through Z here, A through Z here, 0 through 9 here, 0 through 9 there, 0 through 9 there. So there were 26 possibilities in the first spot, 26 in the second, 10 in the third, 10 in the fourth, and 10 in the fifth. What the fundamental counting principle tells us is that if we have this situation for these 5 spots, these 5 possibilities, if we multiply those values together, 26 by 26 by 10 by 10 by 10, excuse me, that's 676 times 1,000, so it's 676,000 different license plate combinations. So that's what it was up until 2005. And then in 2005, they were like, oh crap, that's like not enough license plate combinations. So they changed it over to just 6 digits. And then with 6 digits, it gave you 1,000,000. Oops, one more zero. So that freed up an extra 324,000 possibilities of license plates in Rhode Island. So that's the fundamental counting principle. But that doesn't allow for repeats. Now, let's say there were 7 people standing in line, and we want to find out how many different ways they could all stand in line. There's 7 spots in line. In the first spot, any of the 7 people could be there. But in the second spot, anyone can be there except for the person already in the first spot. So that leaves us with 6 people. In the third, anyone can be there except for the 2 we've already used. So it's 5. Same idea for the fourth spot, the fifth spot, the sixth spot, and the 7th spot. So, if you're looking for the number of orders of 7 people, it's 7 times 6 times 5 times 4 times 3 times 2 times 1, or 7 factorial. So if you are looking for the number of orders of n objects, it is n factorial. All right, there we go. So that's how you can find the number of orders of n objects. But what if you don't care about all the objects? Let's say those 7 people were in a race. There's 7 factorial ways to finish that race. But how many different ways can you have a different podium in that race? So that means a top 3 finish, a gold, a silver, and a bronze winner. So this isn't really just a counting principle. This is actually called a permutation. a permutation is a selection of objects where the order is important. The notation for a permutation, it's a P. The subscript in front is how many you're choosing from. The subscript after is how many you want. So let's say we had those 7 racers and we wanted how many top 3 finishes we can have. It will be 7, choosing 3. All right, 7 in a permutation of 3. So there's really just 3 finishers that we care about. The first place, there's 7 different possibilities. Second place, whoever's first can't also be second. So there's 6 possibilities. And third, whoever's third can't be first or second. So there's 5 possibilities. So in this case, it's 210. And that isn't 7 factorial. That's not 7 factorial. But this is like if you took 7 times 6 times 5 times 4 times 3 times 2 times 1, but divided off the 4 times 3 times 2 times 1. So that's 7 factorial divided by 4 factorial. So we're dividing off all these possibilities from our original factorial. And look at this. How can we get 4 from 7 and 3? Oh, that's right. It's 7 minus 3 factorial. This is true anytime you're trying to find an ordered possibility with a permutation. It is the number of objects possible in a factorial over the number of objects minus the number of selected objects in a factorial. That's how we get a permutation. That's our formula for a permutation. N factorial over n minus r factorial. And this is when order is important. But what if order is not important? What if we don't care about order? What if we're just trying to choose 3 people? Let's say we had a club with 7 people and they just needed a committee to just revise a document, and they just need a 3-person committee to work on that. And there's no leader in the committee, everyone's equal, 3 co-equal members of the committee. This is a combination. When you're taking a selection of distinct objects where the order doesn't matter. It's not important anymore. So instead of a P, it's a C. The subscript in front is the number you have to choose from. The subscript after is how many you are going to be using. Another representation of this is that. These mean the same exact thing. I'm going to need a little more room to write the formula afterwards, so I'm just going to move it back some. And choose R and R. All right. So let's work with the same 7 things, taking 3 at a time. So if order was important, we'd have that 7, 6 times 5. But let's say we had the group A, B, and C. This is the same group BAC. This is the same group ACB. This is the same group BCA, CBA, and CAB. these are all the same if order is not important. So this is not the number of possibilities. This is that permutation. But I'm just going to write the 210 that equals. But for every group of 3 from here, there's 6 of them that are the same. Oops, not 6 factorial, just 6. I was just excited, so I put the exclamation point, but the exclamation point actually means something, not just being excited. My apologies. So it's 210 over 6, which would be 35. That's the number of possibilities. Well, that 210 was 7 factorial over 7 minus 3 factorial. And hold on a second. 6 is 3 times 2 times 1, because that's the number of different orders of 3 things. That was our original idea, putting a bunch of things in order. If you had 3 things in order, there's 3 factorial ways to organize them. So we divide it by 3 factorial. So this was n factorial over n minus r factorial times r factorial. And you may see this written as r factorial times n minus r factorial. Doesn't matter, it's multiplication, so the order's not important. All right, so these are basic counting principles. If you are just have a fundamental counting possibilities in each spot, if order is important or if order is not important. All right, have fun.